there should be some big giant music playing behind me right now because you've been taking limits forever and ever and ever to find derivatives, and guess what? Now they go away. These shortcuts have arrived. They're here. You should be excited. All right, less work, but more work at the same time. Less work as far as writing stuff down, but more work as far as thinking. You ready? I am. Let's go. All right. Okay, so here we have some rules. It's just going to be a series of rules. These are rules that you need to have memorized, okay? So let's take a look at this. The derivative of a constant is 0. Does that make sense? Okay, so if I have a graph where f of x is equal to c, and, okay, here we need to make clear c is a number, okay? So if I have the function f of x equals c, what does that look like? Well, hopefully you can draw this out there, c, right? Here's my function. And you're asked to find the derivative, which is my slope. What's the slope of that? Anywhere. 0. Okay, so let's take a moment and take a look at my notation for this. So derivative of f with respect to x, okay, is equal to, okay, now notice here what I did was I took my function c and put it down here. So this is the derivative of my function c with respect to x. And since there's no x's, my derivative is 0. All right, cool. All right, so this here is a key concept of being able, and we'll get more of that later, and I'll show you this will be something cool later. All right, next. What's the next rule? Next rule, power rule for positive integers. Okay, this is something that you may have already heard in your physics class if you're taking physics C. If I have a function x to any power, and I want to find the derivative of that function, okay, with respect to x, or the derivative of x to the n with respect to x, well, that's going to equal n to the x times n minus 1. Well, what's an example of that? We'll get that shortly, okay? But know that this is my, whatever my power is going to come down and be multiplied, and I'm going to reduce my power by 1. All right, next rule. This is called the constant multiple rule, okay? Below, if u is a function, it's a differentiable function, and x and c is a constant, all right? So u is a function. So u can be any function. That could be like any function. Okay? It could be a polynomial. That could be a rational function. Whatever the case may be, it could be a function. Okay? So now I have to think about, what can I do here? Okay, what is this? So what is this saying? It's saying, well, if I want to make the derivative, well, it's the derivative of the function, that's the u part right here, derivative of the function, times that constant. So I don't really do anything with the c, I just take the c and let it be and take the derivative of it. Okay, so I take the constant, again, c is any number. Okay, again, these are rules, so just we're going to combine them all together here in a short, okay? Okay. So this rule that we're going to do next is saying, hey, if I've got two functions and I add them together or I subtract them, if I have two functions, again, u and v, both are functions. What can I do? Well, if I want to add or subtract them, well, if I just take the derivative of the first function and add it to the derivative of the second function, that's it. Okay? So that's how, I mean, it seems like, duh, that makes sense. So let's see how this all works together, okay? We're going to work this all together. We have a problem right here, example number 1. I want to go ahead and take the derivative of p with respect to t, and here's my function. All right. Now notice, this is a lot of different things going on, right? It's a big function. I can use my rules in very small chunks, all right? So what I'm going to notice is that my very small chunks, I can say that u is equal to t cubed. I can then break it up and say that v is equal to ct squared. I can say that w is equal to 5/3 t. And I can say that, what's a good one here? I don't want to use x, y, or z. Let's use only z is equal to 16. So what I have here is I have that P is now equal to a U plus a V minus a W plus a Z. You can be going, well, why am I doing all this? Because I want to show you, I want to break this down by the rules, and then we'll show you how fast it can go otherwise. So if I want to find dP dt, and I had all these adding and subtracting of functions, well, didn't they just tell me that this would be the same thing as finding du dt plus dv dt minus the dw dt plus a dz dt. So I can just find the derivative of each of these individually. Oh, okay. Well, let's go over here and figure that out. Well, if du dt, well, what is du dt? Du dt, well, that's the derivative. That's going to use my power rule. Power rule, because that's a power. Well, that's going to be 3, because I'm going to take the 3 times 1. My coefficient here is 1, so 3 times 1 is 3. T, okay, and then subtract my power, squared. Done. Now what's the dv dt? dv dt, well, this has got a mixture. This is going to be my constant times the function, right? So it's going to be 6 times the derivative of my function, which is times 2t, and subtract 1 from my power, which is 1, to the first power, which of course I can rewrite as, okay, just 12t. And then dw dt, okay, again, another power rule. My power up here is 1, so 1 times 5/3, that's 5/3. Okay, t to the 0, which is then just 5/3, because t to the 0, any power to the 0 is 0. And finally, dz dt, well, that's a constant rule. The constant rule says if I take the derivative of 16, that's going to be 0. And now I can add these all together. And I come over here and find out dp dt is equal to 3t squared, okay, plus a 12t minus a 5/3 plus a 0. I don't need to write the plus 0. Now, did I have to go through all of this work to do this? I'm hoping you're saying no. I'm hoping that you can see that, well, I can just do this all in a chain. Okay, I can just do 3t, well, that's going to be 3t squared. 6 times 2, well, that's 12t, and minus a 5/3. Okay, using all my power rules. Okay, so I just did it this way so that you can see it all in its glory. My expectation is that you're going to do it like we're going to do number 2 here. Okay, so here comes example number 2. In example number 2, it says here, does this curve have any horizontal tangents? Whoa, 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 whoa. What's a horizontal tangent? So you got to remember, okay, so if I have a graph here, here's a point, here's a horizontal tangent. What do I know about a horizontal tangent? Well, I know that the slope of a horizontal tangent is equal to 0. Well, shoot, if the slope is equal to 0, well, maybe I can find the derivative. Okay, because the derivative will tell me my slope. So if I find, what's dy dt? dy dt. Well, again, I use my power rule, so it's going to be 4 times x, and I'm going to reduce my power by 1, so 4 minus 3. 4 minus 1 is 3. Minus, okay, then it's going to be 2 times 2, which should be 4. X to the 1 less power, 1. Okay, I'm going to just say x. Plus 2, well, the plus 2 is going to be 0, because that's when my derivative is 0. Okay. And now I can go ahead and take a look at this, and it wants tangent to be, so slope is 0. I want my derivative to be 0. So if I want my derivative to be 0, well, here's my derivative. Why don't I just set it equal to 0? So I can say that 0 is equal to 4x cubed minus a 4x. Okay. And what if I go ahead and solve for this? I sit there, well, this way to solve is to factor, and I sit there's 4x, take a 4x out. There's x squared minus a 1. Well, I can factor this even further, and I can say, well, it's 4x times an x plus a 1 x minus a 1. Now we go back to algebra 2 and we say, well, where is this going to be equal to 0? So it's going to be this function is equal to 0 when x is 0, when x is equal to 1, and when x is equal to negative 1. And this is where you've got to stop and think of what you just found. You were given a function of x to the 4th minus 2x squared plus 2. What did you find? You found the coordinates where the slope was 0. Holy cow. Right? I mean, just holy cow. How amazing is that? You want proof? Oh, well, let's go ahead and get you proof. All right? So here we're going to do this. We're going to go to my calculator. Okay? Because that's what we're going to do. We're going to show this. How do we do this? Example 2a says using a calculator, find out where these have horizontal tangents. Okay? All right, so now I'm going to go ahead and use my calculator to go ahead and find this out. And so I'll show you the exact same steps so you can prove how amazing you are. So here I am going to go to my calculator. I've already inputted the functions into y1. Notice in y2 I put the derivative. Okay, that's in math 8. All right, y1 derivative with respect to x. X again equals x, so I want to find the derivative. Notice as well I used my cursor and put it over the equal sign up here on 1 and deselected it, so only thing that we will see is y2, or we'll see the derivative. So when I go ahead and hit graph, bink, here comes the graph. Jinka, jinka, jinka. It's going to take a while because it's doing some high-level computing. And there it is. How beautiful is that? We had 1, negative 1, and 0. And it looks like that's what it is. But you know how you can show it? You know you can find out the zeros, right? I can go second, calculate. And I can go to number 2 for my zeros. Okay? And it wants a left bound. So I'm just going to go a little bit to the left, hit enter, go a little bit to the right, hit enter, and then go back to where I think it is, and hit enter, and there's my 0, 0, 0. And you can go ahead and confirm that also for 1, 1. And I'll go ahead and do that real fast for the positive one. You can do the, okay, I want to calculate a 0, which is a 2. I go a little bit to the left of positive 1. Go a little bit to the right for positive 1. Go back to where I think it is. Press enter. And there it is. It says 0.9999995. Okay, but realize, okay, that's going to be 1. Okay, it only can do so much as far as you're estimating. All right. See if you get a similar result for negative 1. You can pause me if you want to. Please do. Try it on your own. Get the negative 1. If you don't, that's when you ask me questions, okay? Let's go back. Great. So that's how I can find out how horizontal tangents, because again, the slope is 0. How amazing. And I don't even have to do anything. I don't have to graph this at all. Don't have to graph it. It's all done with algebra. It's great. All right, so there we go. Last example. Last rule. So we're going to have something called a product rule, okay? Now this is going to be interesting. Again, u and v are both functions. U and v are both, okay, both functions. And what it's saying is, in a product rule, what I want to do is I want to leave the first one alone, and I want to take the derivative of the second. And I'm going to add that to the result of leaving the second one alone and multiplying it by the derivative of the first. Okay? I'll show you an example. It really should say example 3, but 2a. Anyway, here we go. So here's this example. Now I could go ahead and multiply it all the way out and find the derivative from there. But I'm going to show you how to use the product rule. I'm going to encourage you to multiply it out and find out that it works the same. Okay? So in a product rule, this function is my u, this function is my v. And it said that if I want to take the derivative with respect to x of u times v, it's equal to u, leave the first one alone, take the derivative of the second, plus leave the second one alone times the derivative of the first. Oh, not t, x. I always like using t's. All right. So then what does that mean? Okay, well, I'm going to go ahead and leave the first one alone. So f prime of x is going to equal, leave the first one alone, x squared plus 1 times the derivative of x cubed plus 3. Well, the derivative of x cubed plus 3 is using my power rule. So it'll be 3x, reduce my power by 1, squared, plus 3, well, that'll be 0, because my constant rule says that's going to be a 0. Boom. Okay. Times, or not times, plus, leave the second one alone, so this time I've got x cubed plus 3, and multiply it by the derivative of u. Well, the derivative of u is, well, x squared becomes 2x to the power of 1, plus 1, well, that's just 0. Boom. And then I go ahead and see here that I multiply this out. And when I multiply this out, this will be equal to 3x to the 4th plus 3x squared plus 2x to the 4th, okay, plus 3x. And I can go ahead and combine like terms. This is equal to 5x to the 4th plus 3x squared plus 3x. And that's what f prime is. Okay. My encouragement to you, since I'm already pushing time in this, okay, is I want you to go ahead and multiply this out first. Okay, do the FOIL this out, and I encourage you then to take the derivative of that FOIL and show that it's the same. Okay. In fact, I want you to do that. I'm going to pause the video right here at the end. And now, here's your homework. 1 to 13 odd. If you have questions, email me. Leave them behind. I'll take a look at them.